Welcome to Star Pencil, Basic Understanding Concepts. So this is the continuation class in the polynomial equations. This class we will see the relation between roots and coefficients. This class we will learn about relation between roots and coefficients. Okay. So I will write again a polynomial equation, first order, second order, third order. Okay. So I am writing on one of the polynomial equations. Polynomial equation always we write p of x is equal to ax plus b. Okay, this is the first order polynomial equations. What do you call here? A is the coefficient of x. Okay, coefficient of x. Okay, b is equal to constant, right? We know all this, right? I'm writing another polynomial equation, the second order. Second order is also called quadratic polynomial equation. So that we can write here ax square plus bx plus c. This is a general form I am writing. Here a is the coefficient of x square, b is the coefficient of x, and c is the constant here, right? Similarly, I am writing cubic equation. Okay, p of x is equal to ax cube plus bx square plus cx plus d. In this equation, a is the coefficient for the x cube. Similarly, for b is the coefficient for x square, c is the coefficient for the x, and d is the constant, right? Okay, so how many roots has the linear equation? Linear equation is the maximum one root. Let's take, so what is the root? For what value of the x, p of x will become the 0 is called the root, right? So let's take alpha is the root for this equation. Okay, alpha is the root. This is a constant number and it is a root for this equation. How you are taking here the constant a, b, c, right? Similarly, I am taking that alpha is the root for this equation. Okay, you can take any alphabetical or any kind of symbol to denote the some constant which satisfy the p of x is equal to 0 equation, right? So I am taking here alpha is the root to satisfy the p of x to 0. So what does that mean? When you substitute x place alpha root, okay, then you will get this equation makes to 0. Okay, then a into alpha is equal to minus b. Alpha is equal to, so minus b by a. So for the linear equation, root is equal to, root means alpha satisfies the equation, right? That's why we are calling the root of this equation, right? So alpha is equal to minus b. So this is a relation between the coefficients and coefficients with root. Okay, so what is the minus b? Minus, what is the b actually? Constant, right? Constant in this equation, constant, right, divided by what is the a? Coefficient for the of x, the coefficient of x, right? So this way you can find the root directly for the linear equation. Okay, so now how do you deal with the quadratic equation? So I am rewriting here again for the quadratic equation. See, quadratic equation is p of x is equal to ax square plus bx plus c, right? So how do you find the roots for this equation? We will make the p of x is equal to 0. That means the quadratic equation is ax square plus bx plus c is equal to 0, right? So here I am taking, how to find roots of this one? Okay, what is the relationship it has between the roots and these coefficients? Okay, let's take alpha and beta are the roots of this equation. So in always in mathematics, right, we do whichever we do not know, we'll take some alphabetical or some alphabetics. We will take it initially and finally we will try to find them. Okay, so now I'm assuming alpha beta are the roots of this equation. Okay, what does that mean? When you substitute alpha into that equation, it satisfies completely. Okay, means it will become the 0. Okay, and if you put beta into that equation, then it will become 0. Okay, that means I'm just substituting. I'm substituting alpha into this equation. Then what we get? A into alpha square plus b into alpha plus c is equal to 0. Similarly, beta also it satisfied if the beta is also root of this equation, right? So a into beta square plus b into beta plus c. Okay, so now we have the two equations here. Okay, so what I will do here, this is the I'm just taking the equation number 1. Okay, and this is the equation number 2. Now I will just subtract the equation number 1 minus 2. Okay, I am writing here 1 minus 2. Okay, if you subtract left side to left side and right side to right side, also it becomes 0, right? So why? Because this entire term I am just subtracting to this entire term, and the right side also 0 minus 0. Okay, so I am writing here both equations here for simplicity. A alpha square plus b alpha plus c is equal to 0. I am writing again here a beta square plus b beta plus c is equal to 0, right? So what I said, I am subtracting these two equations. Okay, so you can add or subtract anything. Why I am subtracting? Okay, anything you can do it becomes satisfied, because anyhow this is entire thing is 0, this entire thing is 0, and this is also 0 0. Okay, you subtract or add anything, right, it has to become 0 0. Okay, so that's the reason we are adding or subtracting. Can do anything by subtracting. What we get, right? So the c terms can be eliminated from this equation. That's what I am trying to do it here. Okay, so when you subtracted a alpha square minus a beta square, right, plus b alpha minus b beta, and c will become c minus c. Okay, is equal to 0 anyhow. Okay, so here we take the a as the common. Okay, alpha square minus beta square, take the common here, take the b also common here, alpha minus beta, right? So anyhow TC is not there here. Okay, right? So what we can do it here, we can take the common of the alpha. You can write alpha square minus beta square as alpha plus beta into alpha minus beta, right? We know this term, plus b into alpha minus beta is equal to 0. Take the common alpha minus beta here. Okay, alpha minus beta, if we take common, in the first term we have a into alpha plus beta, second term we have the b, right, is equal to 0. Last expression I am rewriting here. What you get in the last expression here, alpha minus beta into, right, so I am rewriting here. Okay, alpha minus beta into a into alpha plus beta plus b is equal to 0. Okay, how this term will become? Either alpha minus beta becomes 0, then it is 0, right? Or if this is becomes the 0, then also it will become 0. For example, you have the two numbers to multiply. Either one number becomes 0 is sufficient to make the 0. Okay, in order to be both becomes 0. In the first case, you can say that if alpha minus beta is equal to 0, then this will become 0. That means alpha is equal to beta. That means both roots are the same. Then this equation becomes 0. The another one, either a into alpha plus beta plus b is equal to 0, then also it will become 0. Here I am taking roots into the one sides. Alpha plus beta is equal to minus b. Okay, alpha plus beta is equal to minus b by a. So this is the one of the relationship we're deriving for the roots. What does it mean? Sum of the two roots. These are the two roots, right, for the quadratic equation. So sum of the roots is equal to minus b by a. That means, so what is the equation we assumed initially? It is ax square plus bx plus c is equal to 0, right? This is the quadratic equation, right? So here what is the b? Minus coefficient of x divided by coefficient of x square. Okay, so always denominator we get the coefficient of the highest degree. Okay, that is x square degree. So this is the one of the relations for the roots. You need to remember this relationship. So sum of the two roots is always equal to minus coefficient of the x divided by coefficient of the x square. Okay. Similarly, we can have another relationship we can derive. Okay. As I said, we have the two equations which satisfy this quadratic equation. Alpha beta, if alpha beta are the roots, right? I am rewriting here. Okay, a alpha square plus b alpha plus c is equal to 0. Another one, a beta square plus b beta plus c is equal to 0. So last time we eliminated these c terms, okay, by just subtracting these two equations. Now we will eliminate this b term. How we will eliminate? So if I'll take a write this is equation number 1 and this is equation number 2. So how will you eliminate? This is a b alpha and this is a b beta, right? So how do you get the same numbers? If you multiply the first equation with beta, okay. So what I'm doing is that one equation I'm multiplying with beta. Then what I get? A beta alpha square, right, plus b beta alpha plus c beta, right, is equal to 0. 0 into beta is also 0, right? So okay, then in the second equation I'm multiplying with alpha. Okay, so what I get? A alpha beta square plus b alpha beta plus c alpha is equal to 0. So now what I am trying here, right? Again I am subtracting these two equations after multiplying with this. Okay, I am putting minus sign here. Subtracting is minus sign changes, right? So from these two I am writing here a beta alpha square minus a alpha beta square, right? I subtracted first term. The second term will get cancelled. You can see here b alpha beta is there, right? So beta alpha multiplication, it will become same. Okay, so we are cancelling this term. So now when is subtracted this one, c beta minus c alpha is equal to 0, right? Now what I can take common here, a alpha beta I can take common, right? To take common, what I get, what is left here? Okay, it is left here, is alpha is left here, minus here beta will be left here, right? Plus, you can take common anything here? No, you can take c, you can take common, that will become beta minus alpha is equal to 0. I am rewriting over here, a alpha beta into alpha minus beta. Here I am taking the minus common, okay, to make it same, okay, minus c into alpha minus beta, changing the direction, is equal to 0. From these two we can take common alpha minus beta, right? If you take common alpha minus beta, in the first term we get a alpha beta minus c, right, is equal to 0. So how will this equation become 0? If alpha is equal to beta, then it will become 0. Okay, so we don't get anything from here, because every time we'll take other term here. So a alpha beta minus c is equal to 0. That means a alpha beta is equal to c, right? Alpha beta is equal to c by a. Okay, so this is the another form of between the relations between the roots and the coefficients. So when you sum up the roots, okay, we get minus b by a. When you multiply the roots, we get c by a. C is the constant, okay, divided by max power coefficient, okay, that is x square coefficient, okay, coefficient of x square, right? So now we have two relations between the roots and the coefficients. Alpha plus beta is minus b by a, alpha into beta is c by a. So I am simple way I am writing here, okay, I am making one space here, okay. This is the x square plus bx plus c is equal to 0 equation. If alpha beta are the roots for this equation, okay, roots means it satisfies this quadratic equation, then what you know is alpha plus beta is equal to minus b by a, alpha into beta is equal to c by a, right? Good. So I am rewriting quadratic equation one time over here. Quadratic polynomial equation, that is ax square plus bx plus c, right? So we derived the, if the alpha beta are the roots of the quadratic equation, then we know that sum of the two roots is minus b by a, and product of the two roots c by a. Okay, this is we derived, okay. There is another simple form of deriving this equation, okay. So I'll first know, instead of this direct quadratic polynomial equation, I will write up with some examples so that we will understand better, okay. So I am taking another quadratic polynomial equation, that is 2x square minus 8x plus 6 So when it making 0 only, you can find the root. So that directly making is 0. That we are calling the equation quadratic equation. When make it to 0, it's called that quadratic equation. When we are writing the polynomial form, it's called quadratic polynomial equation, right? So okay. So how do we find the roots? So we can find the roots by factoring the middle term. Okay. So we can make it factorize the middle term and we can find the roots. So I'm rewriting here, you can see it here. Okay, 2x square. So we can write minus 8x as minus 6x and minus 2x plus 6 is equal to 0, right? So if you make it sum these two, right, then we'll get the minus 8x. I am writing minus 8x into minus 6x and minus 2x. So if you sum these two, we get minus 2x. So that there is no change in the equation. Okay, from these two terms, you can take some number as a common, right? So from this, you can take 2x as the common, right? So what you get here, here is the x minus, here is the 3. 2 3s are 6, right? So similarly, if you take common here minus 2, okay, then you get x minus 3, right, is equal to 0. So how, right, you are taking minus as the common. So minus 2 into x minus 2x minus 2 into minus 3 plus 6, right? That's it. It's minus 2. If you take common, it's become x minus 3. Again, you can take common as x minus 3 here. Okay. If you take common x minus 3, you get 2x minus 2, right, is equal to 0. Again, you can take common here 2. If you take common 2, it become x minus 3 and x minus 1. Okay. So for any quadratic equation, okay, if you factorize it, right, if you make it factorized, so we get one constant as a common. We may not get, but I'm just saying we get the one constant as a common, and we get two factorized terms. Okay, so so in this equation, to make it 0, either x minus 1 is equal to 0 or x minus, okay, this will become 0 when x minus 3 is equal to 0, it will become 0. When x minus 1 becomes 0, also it will become 0, right? So 2 cannot be 0, this constant cannot be 0. So now x is equal to 3 and x is equal to 1 here. So now here 1 and 3 are the roots of the quadratic equation. Okay, you can check it out if you want to quickly, right? I can check out this equation, right? So what I'm saying, 1 and 3 are roots of the quadratic equation. 2x square minus 8x plus 6, right, is equal to 0. I am trying to substitute 1 into this equation. You can see here 2 into 1 square minus 8 into 1 plus 6, that's equal to 2 minus 8 plus 6, that is 0, right? So if you substitute even 3 in this quadratic equation, okay, 2 into 3 square minus 8 into 3 plus 6, 2 into 3 square is 9 minus 8 into 3 plus 6, right? So here 18 minus 24 plus 6, this is also become 0. So here 1 and 3 are roots of the quadratic equation, right? So so if 1 and 3 are the roots of the equation, right, then in factorial term we got an expression that 2 into x minus 3 and x minus 1 is equal to 0. We got it right in fact last time. So I am rewriting the quadratic equation one more time here in the general form here. Ax square plus bx plus c is equal to 0. If it's a quadratic equation, let's take alpha beta are the roots of this polynomial equation, right? So roots of this quadratic equation. So I'm writing in factorial way these roots, okay? So I'm writing as k is the constant. In the previous example, we got the k as the 2 as the number, okay? Okay. So 2 as the number, but in the general quadratic equation, I'm taking k as the constant, and x minus alpha is the first root, and x minus beta is the second root, right? Okay. So I'm simplifying this term actually. So left hand side I'm just simplifying. Instead of writing equal to 0, I'm just simplifying the left hand side, right? Left hand side of this one, okay? Then k into, if you multiply these two, okay? How do you multiply x into x? We'll multiplying like this, x into x and x into beta, right? First, so x into x, x square, x into beta minus x beta, right? Similarly, we do with this way, right? So alpha into x minus alpha x and minus plus alpha into beta, right? Okay. If you multiply the k, it's become like kx square minus k beta x minus alpha k x plus alpha beta k, right? Again I'm writing here simple kx square, I'm taking common here, okay, plus x I'm taking, so what we get, minus k beta minus k alpha plus alpha beta k, okay. If you compare our whatever the equation, right, whatever the equation here, this is the quadratic equation. When you compare this equation, what is x square coefficient here, k, here is the x square coefficient a, so we can derive from this a is equal to k, okay. What is the x coefficient, it's the b here, so b is equal to, what you can put it here, here is minus k into beta minus k into alpha, right? What is the k here? K is the a, right? If you take common k, okay, minus k, if we take it, this alpha plus beta, right? So what is alpha plus beta? Alpha plus beta is equal to minus b by k, right? Okay. So what is the k? K is the a, okay. So alpha plus beta is equal to minus b by a, okay. This is the first derivation which you did the last time, okay. The another version, if you constant, if you compare alpha beta, k is the a, right, is equal to c, right? Then become alpha beta is equal to c by a, okay. This is the another expression. So we can derive with two different forms, okay. One, we derived by substituting the roots into the main equation, and we eliminated some of the terms by adding or subtracting. Another way is in the factorial way, we found the relation between the roots and the coefficients, right? So I'm writing in the box here. So in this also I'm rewriting the things, okay. It is if it is a ax square plus bx plus c is equal to 0 is the quadratic equation. For this alpha beta are the roots of this equation, then we know that alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a, right? Now we will see how this relationship holds for the cubic equation. So I am writing general form of the cubic equation. Okay, so that is ax cube plus bx square plus cx plus d. Okay, this is equal to 0. Actually, it's again I can writing the polynomial equation like p of x is equal to ax cube plus bx square plus cx plus d, right? And where this become, how to find the roots of this equation when p of x is equal to 0. That's where I written the general form as ax cube plus bx square plus cx plus d is equal to 0. Okay, let's take roots of this equation is, so for cubic equation how many max roots can be there? 3 roots can be there, alpha, beta and gamma. These are the Greek letters. Okay, we use for the just for the representations, like, right, alphabetics. Alpha, beta, gamma are the, let's take are the roots of this. Okay, roots of the cubic equation. Okay, then we have the following relationship to be satisfied. We can do it by substitute, right, whatever I given, right, we can substitute alpha and eliminate some of the terms, then we can derive these of things. So I'm not deriving it. I think if you derive it, we will get something like this. Okay, alpha plus beta plus gamma, sum of the roots, this is called sum of the roots, is minus b by a, and you need to be multiplied this way. Okay, alpha into beta, alpha into gamma, right, then beta into gamma, right, this way you need to multiply it. Alpha into beta plus beta into gamma, so what makes it gamma into alpha. So 3 combinations, so these two, these two, these two, get it, right? Alpha, beta, beta, gamma, alpha, gamma, right? So if you multiply all this, that is equal to c by a. And another this, if product of the 3 roots, alpha, beta, gamma, is equal to minus b by a. So how do you derive it? So as I said, right, so if you take alpha, beta, gamma are the roots of the cubic equation, it must satisfy. Then the first equation you get a into alpha cube plus b into alpha square plus c into alpha plus d. Okay, this become the first equation. So another equation you get a into similarly beta cube plus b into beta square plus c into beta plus d is equal to 0 is the second equation. Okay, third equation you get a into gamma cube plus b into gamma square plus c into gamma plus d is equal to 0. Okay, so with these 2 equations you can eliminate the d, with these 2 equations you can eliminate d, and by multiplying you can eliminate c. So doing all this exercise you can find these 3 relations. Okay, you can find these 3 relations. Do it yourself. If you have any questions or know how to do it, please write in the comment section. I will try to explain in the comment sections. Or if you really want derivations of these 2, please comment it. Okay, I will make another new video on this.